Okay, welcome back, friends. So in the previous session we have seen that how to calculate or how to operate or how to perform the operations on discrete time signals. Okay, so we have seen how to do the time shifting, how to do the time reversal, and how to do the time scaling. In the time scaling we have seen both the things, which is the decimation and interpolation also. So in the decimation we will get less samples, that's why it is called as downsampling. In the interpolation we will get more samples, that's why it is called as upsampling also. Okay, so let's see one problem, and here I will make some statements also based on this problem. Let's see. Example: x of n is equal to 2, 3, 4, 5, 6, 7. Here is the arrow. Suppose, example, it is given that find x of 2n plus 1. I want to calculate this. Given x of n, so from that we have to calculate x of 2n plus 1. So here also we can go with the natural method and unnatural method. So let's see what will happen if I go with the natural method, what will happen if I go with the unnatural method. Suppose, let's say method 1. Method 1, that means I can calculate x of 2n plus 1 in this direction. This is the direction. So first what we have to calculate? X of n plus 1. That means arrow has to move in the right side by 1 unit. That's what the x of n plus 1. Next I can calculate x of 2n plus 1. That is, n is replaced with 2n. That means we have to keep the 0th position as it is and pick every second sample towards right and left. Then what we are going to get? 3, 5, 7. So this is what the natural method. If I perform unnatural method, then what will happen? Method 2. Method 2. That means I can go in this direction to perform these operations, x of 2n plus 1 in this direction. That means if I take 2 common out, n plus 1 by 2. So in this case, first I will go x of 2n. How we can calculate x of 2n? Keep the 0th position as it is and pick every second sample. 2, 4, 6. Next, x of 2 into n plus 1 by 2. Is it a possibility? No, we cannot calculate this. We cannot calculate this. Why we cannot calculate this one? Because it is involving a non-integer shifting, which is 1 by 2. I told you, in a discrete time case, non-integer shifting is not possible. So for this particular example, method 1, that is a natural method, is feasible, whereas method 2 is not feasible because it is involving a non-integer shifting. So method 2 cannot be applicable because it involves non-integer shifting. Non-integer shifting. So we always have to avoid non-integer shifting. So this is the correct answer. We can go with the method 1 only. Okay. Please make the notes. So, next. Suppose they want to calculate x of n by 2 minus 1 by 2. X of n by 2 minus 1 by 2. So here also we have to perform multiple operations. Let's see whether the method 1 is feasible or method 2 is feasible. Okay. So let's go with the method 1, whether it is going to be helpful or not to calculate this one. Method 1, x of n by 2 minus 1 by 2. That means in this direction we have to perform the operations. That means we have to first calculate x of n minus 1 by 2. Here itself we cannot calculate. Why? Because it is involving non-integer shifting. So that one is not possible. So method 1 cannot be applied to calculate the given function. Okay. Then what we can do with the method 2? Let's see. Method 2. In the method 2, x of n by 2 minus 1 by 2. We can perform the operations in this direction. That means we have to take 1 by 2 common. If I take 1 by 2 common, n minus 1. So in this direction we have to move. So if you observe carefully, it is not involving any non-integer shifting. It is not involving any non-integer shifting. So yes, this method is okay for us. That means first we can calculate x of n by 2. That means we have to insert 1 0 between the samples. 2 0, 3 0, 4 0, 5 0, 6 0, 7. Here is the arrow. Next, x of 1 by 2 into n minus 1. That means arrow has to move 1 unit in the leftwards. So we are going to get 2 0. Here is the arrow. There is the arrow. So that's what the final answer we are going to get. So here in this case method 2 is okay. So there is no conclusion which method we have to use, whether it is a method 1 or method 2. It doesn't matter, but only one thing you have to keep it in mind, that first avoid non-integer shifting. That's the only thing we have to do. First avoid the non-integer shifting, then whichever the method which is involving or which is avoiding non-integer shifting, that method is we have to perform. Okay, take it. Suppose in a particular example, if you try to calculate this one, let's see what will happen. X of 2n plus 2. Suppose if I am trying to calculate this one. So which method I can go with? Either of the method is okay. Why? Let's see. Method 1. In the method 1, x of 2n plus 2, to calculate in this direction we have to perform the operations. That means let's say x of n plus 2. Arrow has to move right side direction by 2 units. 2, 3, 4, 5, 6, 7. 2 units means here is it. X of 2n plus 2. Now we have to decimate by 2. Decimate by 2 means keep the 0th position as it is. Every second sample, no, this one, this one. So finally I can get 2, 4, 6. Here is the arrow. That's what we are going to get. Clear. Let's go with the method 2. Method 2 means x of 2n plus 2. In this direction we have to go. So that means if I take 2 common out, n plus 1. So it is also not involving any non-integer shifting. So we can go with this method also. That means first we can calculate x of 2n. X of 2n means we have to pick every second sample, that means 2, 4, 6 only. Next, X of 2 into n plus 1. Arrow has to move 1 unit in the right side direction. 2, 4, 6. Here is the arrow. Yes. If you observe carefully, both the answers are same. Yeah. Method 1 is applicable. Method 2 is also applicable. Okay. Take it. To find X of, let's say, 2n plus 1 by 3. To calculate this, whatever the method you use, it doesn't matter. It always involves a non-integer shifting. Suppose if I go in this direction, it is also not possible because we have to make 1 by 3 shift, which is not a possibility. Suppose if I go in this direction, X of 2 common out, n plus 1 by 6. So that is also not a possibility because that is also involving non-integer shifting of 1 by 6. So either of the direction if you go, it's not possible. So this kind of signal does not exist. Okay, we cannot perform that kind of operations. Okay. Let's take one question, previous GATE question, so that we can understand. 10th question. Sorry, it's a 9th question. I will read the question. Question number 9. If x of n is given, to find y of n, which is x of 3 minus 4n. Which of the following procedure is correct? Which of the following procedure is correct? Okay. Let's say the options: delay by 3 samples, pick every 4th sample, and time reversal. And time reversal. That is option A. Option B: advance by 3 samples, pick every 4th sample, and time reversal. And time reversal. Next, option C: pick every 4th sample, comma time reversal, and delay by 3 units. Three samples. Option D: pick every 4th sample, time reversal, and advance by 3 samples. So, which of the procedure we have to follow to calculate x of 3 minus 4n? Okay. Listen carefully. I can rewrite this one as x of minus 4n plus 3. Just I jumbled here. Minus 4n plus 3. Let's see. First, if I go with a natural method, this is the natural method. Or if I go in the unnatural method, if I take minus 4 common, n minus 3 by 4. So unnatural method is not a possibility. Only natural method is possible, because in the unnatural method it is involving a shift of 3 by 4, which is not a possibility because non-integer shifting. But let's say In this direction if I go, it is not involving any non-integer shifting, so I can go with this method. Let's see. In this direction, first what we are seeing, plus 3, that means we have to advance by 3 samples. Next, pick every 4th sample, then time reversal, which is nothing but option B is correct. I hope you understood what I am trying to say. So this is the procedure what we have to follow. This is the sequence. Plus 3, advance by 3, 4n, that means pick every 4th sample minus time reversal. Okay, take it. Let's go with the next very important one. We have to write the given waveform in terms of u of t and r of t. Okay, so writing the waveform in terms of u of t and r of t. Let's see. For that, first we have to understand some of the things. Okay, this is the concept. If I say draw 2 u of t, how we can draw this? Whose amplitude is 2 after t equal to 0. If I say draw 3 u of t minus 2, can you draw this? Yes. This is nothing but it is starting at t equal to 2, whose amplitude is 3. This is the one way. Next, if I say draw u of minus t, we can draw this also. Suppose if I say draw u of minus t plus 2. So already we got u of minus t plus 2 means we have to delay by 2 seconds. If I delay by 2 seconds, this is what we are going to get. If I say draw u of minus t minus 3, then this is existing up to minus 3. That is what we are going to get. Okay, so these are very, very important. First take down this, then we will see some more points. What are the observations we made? These are easy to remember. U of minus t plus 2 means it is up to plus 2. U of minus t minus 3 means it is up to minus 3. Okay, minus t means it has to go up to infinity, in the negative direction, minus infinity. Okay. Okay. So this is one way, one thing you have to remember. Let's see. Again, coming back to these waveforms. What we have seen, how to draw these waveforms, we already know. But let's see these waveforms in a very different manner. Let's say 2 u of t. Can I say it is going to introduce, or it is introducing a jump or discontinuity at t is equal to 0? Next, let's come into this one. U of t minus 2. It is going to introduce a discontinuity at t is equal to 2. Next, how much jump or how much discontinuity it is going to introduce? That is nothing but 3 units. That is nothing but the coefficient. Or 2 is nothing but the coefficient, which is nothing but the amount of discontinuity or amount of jump, we can say. So suppose in general it is given like this. In general, k u of t minus t naught is given. K u of t minus t naught is given. From this you have to understand this t naught is nothing but the location of jump, or location of discontinuity. Location of discontinuity. What is this coefficient k indicates? This is nothing but change in amplitude or amount of jump. That's what the k indicates. Okay. So just remember, step function introduces a jump, or we can call it as a discontinuity. Okay, take it. So you can understand easily. Just see this one. U of t plus 1 minus u of t minus 1. So here we are having two step functions. One is at minus 1, one is at plus 1. Understood? Now they are going to introduce two jumps at minus 1 and at plus 1. So whenever you want to draw this kind of waveform, first take the time axis and represent the point of discontinuities. Where are they? One is at minus 1, another one is at plus 1. In the ascending order, this is the order. So minus 1 plus 1. Let's. Then we have to draw this. Up to minus 1, assume initial amplitude is 0. At minus 1, how much amount of jump it is introducing? How much of amplitude it is introducing? That is nothing but coefficient, which is 1. So up to this point it is 0. Suddenly it will go to a new value, which is nothing but 1. The new value is 1. It will continue up to this point. Next discontinuity. So up to next discontinuity, it is going to be continue. Next, at 1, if you observe carefully, how much the jump it is introducing? Minus 1. Already 1 is the amplitude. For that, if you introduce a minus 1 amplitude, then it will drop to a new value, which is nothing but 0. And that 0 will continue. There is no next discontinuity points. This is the waveform you are going to get. Okay, take it. Next, draw the waveform for the given expression. U of t plus 1 minus 2 u of t minus 1 minus 2 u of t minus 2 plus 4 u of t minus 3. Please try to draw this one. Again the same thing. First write the discontinuity points in the ascending order and check. So just up to the first discontinuity, it is going to be 0 amplitude. From that, what are the jumps, how much it is going to be, like that. So what are the discontinuity points? -1, 1, 2, 3. These are the discontinuity points, 4 discontinuity points. Let's see. Up to -1, the initial amplitude is 0. At -1, it is introducing a jump of 1 unit. That means up to -1 it's 0. If I am adding 1 again to it, so it will go to a new value which is nothing but 1. It will continue up to next discontinuity. At 1, it is introducing -2. Already 1 is the amplitude. If I am introducing -2, then the new amplitude is going to be -1. So it will jump to a new value which is -1. It will continue up to next discontinuity. At 2, it is introducing again -2. That means it will again drop to, already -1 is the amplitude. Again if I add -2, it will drop to a new value which is nothing but -3. Up to next discontinuity. At 3, it is introducing +4. Already -3 is the amplitude. If I introduce +4, then the new value is going to be +1. So it will jump to a new value which is +1. And it will continue like that. Why? Because there is no next discontinuity point. So it will go up to infinity like that. Final amplitude is 1. Okay, take it. Next example, draw this function 2u of t plus 2 minus 3u of t plus u of t plus 1. Draw this function. -2, 0, +1. These are the point of discontinuity, 3 discontinuity points. So up to -2, the amplitude is 0. At -2, it will jump to a new value which is 2. It will continue up to 0. At 0, the introduced amplitude is -3. So it will jump to a new value -1. Up to 1, okay. At 1, it is introducing again +1. So already -1 is there. If I introduce +1, finally it will jump to a new value which is 0. So this is what we are going to get. Okay. So here we have to observe some points here. What is the final amplitude we got? 1. What is the final amplitude we got? 1. If you observe carefully, this is nothing but the sum of the coefficients. 1, -2, -2, 4. So this is 0 and finally we got 1. Next, what is the final amplitude? That is nothing but 0 here. If you observe carefully, the sum of the coefficients 2, -3, +1, that is also 0. So I can simply give the sum of the coefficients of the expression is nothing but the final amplitude. Final amplitude. So these are the observations what we can say. Final amplitude is equal to sum of the coefficients. Sum of the coefficients. This is the one observation what we made. Next, second observation. If you observe carefully, whenever the sum of the coefficients is 0, can I call the signal is nothing but finite duration signal? Why it is a finite duration signal, sir? Let's see. The signal is existing only between -2 and +1. After that, it is going to be 0. Means the signal is existing between -2 and 1 means it is existing only for 3 seconds. That means it is a finite duration. Whereas coming to this one, the signal is existing between -1 and +infinity. It will go up to +infinity. So finally, the duration of the signal is nothing but infinity. So we can say this signal is called as infinite duration and this signal is called as finite duration signal. The duration, the existence means the non-zero value of the signal is present for finite duration. So we can say it is a finite duration signal. Okay. So I can say if sum of the coefficients is equal to 0, that implies signal is finite duration. Signal is finite duration. Okay, make a note. Suppose if the signal is given, till now we have seen expression is given how to write the waveform. Suppose if the waveform is given, how we can say the expression? Let's see. Okay. So this is the signal x of t is given. They want to find out expression for x of t. So if you observe carefully, so it is a step functions only. So we are having only steps. Whenever the signal is involving only steps, then we can completely express x of t in terms of u of t. That means shifted step signals. So shifted step signals can be used to express x of t. How we can do that? Let's see. So first we have to understand we are having step functions at -3, -1, 1, 2. Why? Because they are the point of discontinuities. They are nothing but the point of discontinuities. Okay. Now at -3 we know that the step function is nothing but u of t plus 3. That's everybody knows it. But what is the coefficient of that? Then to understand the coefficient always given the amount of jump. That means change in amplitude. How much is the change in amplitude? Already 0 is there, 2 is there. So change in amplitude is 2 minus 0. That means jump is equal to 2 here. At -1, how much is the jump we are having? Already amplitude is 2 is there. Then we are having 3. 3 minus 2, jump is equal to 1 only. Next, at this point jump is in the downward direction. 3 becomes 2. 2 minus 3, jump is equal to -1. Here jump is equal to -2. They are nothing but the coefficient. So if I write the expression x of t is equal to 2 u of t plus 3 plus u of t plus 1 minus u of t minus 1 minus 2 u of t minus 2. So that's what the expression for the x of t. I hope you understood. So at these points we are having the step function and the coefficients are given by the amount of jump. Okay, take it. Write the expression for x of t. Write the expression for x of t. Here also we are having steps at 0, 1, 2 and 3.5. So we just have to represent the jump values. Jump is equal to 0.5. Jump is equal to 0.5 to 4.5. That is nothing but 4. 4.5 to 7. That is 2.5. Understood? So that's what the jump values. But at 3.5 there is a downward jump because it is decreasing. So jump is equal to -7. Then we can write x of t is equal to at 0, 0.5 u of t, at 1 plus 4 u of t minus 1, at 2, 2.5 u of t minus 2, at 3.5 that is minus 7 u of t minus 3.5. So this is the way we can represent the given waveform in terms of step functions. Okay, take it. So let's see. If I say simply r of t, how we can draw this? This is what the r of t function, where the slope of this line is given by 1. If I write 2r of t, how we can draw this? Same, which is a steep line, slope is equal to 2. What do you mean by slope is equal to 2? That is 1 unit change in x-axis. Suppose if the 1 unit change in x-axis is going to result 2 units change in the y-axis. That's why 2 by 1 slope is equal to 2. Suppose let's say r of t minus 3. So the step function, sorry, the ramp function is starting at 3, not at 0. So it is starting at 3. So this is the one. Here still the slope is equal to 1. What do you mean by slope is equal to 1? Suppose 1 unit change in x-axis, that is 3 to 4, there is only 1 unit change. So how much change in the y-axis? That has to be 1 unit only. Then only the slope will become 1. So that's what the r of t minus 3. So in general, k r of t minus t naught is given. What it will do? So first try to understand this one. R of t, what it is doing? Up to 0, the slope is equal to, the slope of a horizontal line is nothing but 0. At 0, it is introducing a slope of 1. That's what the meaning of it. Next, 2r of t means up to 0, the slope is 0. At 0, it is introducing a slope of 2. Next, r of t minus 3 means up to 3, the slope is equal to 0. At 3, it is introducing a slope of 1. That's what the meaning of it. So wherever the slope changes, those points are called as corner points. So I can say this t naught is nothing but location where slope getting changed, or simply we can call it as corner point. This is corner point. And what the k indicates, that is change in slope. Change in slope. What do you mean by change in slope? That is nothing but final slope minus initial slope. Minus initial slope. Final slope minus initial slope. Let's say 3 is the corner point because there is a slope change. How much is the slope change? Final slope is equal to 1. Initial slope is equal to 0. 1 minus 0. 1 is the coefficient. That's why we got coefficient is equal to 1. I hope you understood. Okay, take it.